Okay, good morning. Please put your pencils down and pick up your colored pens. Everything that we do for the next few minutes will be done in colored pen. I will have you pick up your pencil though in a few minutes. Today's warm-up is a review of ideas scattered throughout the recent past. Let's see how we did with these questions. Stay on your toes today. The equity bars are in full effect. So for number one only, I would like X, the midpoint of segment AC. Students 21, student number 20, student number 1, and student number 5. Student number 20, student number 1, student number 5. Student number 20, what did you get? Student number 1. Student number 5, what did you get? The midpoint of segment AC is 3, 5. Number 2, Y, the midpoint of segment CB. I got students number 6, 3, and 16. 6, 3, and 16. Student number 6, what'd you get?
8, 5.
Student number 3, what'd you get?
8, 5.
Student number 16, what'd you get?
8, 5.
So all of you agree that the midpoint is 8, 5. What about number 3, AB? What is the distance of AB? I got student number 4, 14, and 9. Student number 4, what'd you get?
10.
Student number 14, what'd you get? Student number 9, what'd you get? That's you, Sharik.
Okay. 10.
The distance is 10. What about the slope of segment AB? What did you get for the slope of segment AB? I've got students 4, 15, and 14. What did you get?
0.
Number 15. Okay, student number 14. The slope is 0. And what about the slope of segment XY? I got student 8, 1, and 17. Student number 8, what'd you get? Student number 1, what'd you get? Students, stay on your toes. I'm calling on.
0.
Student number 17, what'd you get?
0.
The slope of segment XY is 0. So mark your answers correct, you're incorrect, of course. But now let's do a little observation. Anyone notice anything? Anybody notice anything? Any observations at all? Kadir?
If like if 2 of the points are like on the same, they have the same line, the slope is 0.
If 2 points are on the same line, the slope is...
If they have the same line.
Oh, if they have the same y. Oh, absolutely. So you see that they have the same y, and I asked you the slope of that line, and if they have the same y, the slope is going to be 0. Very good observation. Any other observations? Ziamar?
A, B, and X, Y are parallel.
Are they?
Yeah, I have the same slope.
So these two lines are parallel because they have the same slope. Very interesting observation. I wonder why that happened. So you know what? I'm not sure what it looks like, but here's what I want you to do, because this relates to what we're going to learn today. I want you to graph, so you're going to draw a grid. I want you to graph A, B, C. And then I want you to connect the dots to form a triangle. Then I want you to plot X, Y, and I want you to connect those two dots to draw a line. That should take you about 2 minutes. So let's put 2 more minutes on the clock and see if we can form a graph of these. All I'm asking you to do is 5 points and 4 lines. There's still about a minute left on the clock. I actually added a minute. If you're all done on your team, compare your picture with your teammates. See what you guys can come up with as far as observations. What do you notice? Xiomara said that segment AB and segment XY were parallel. She said because they have the same slope. Well, now look at the picture. What else can you observe? You have about 20 seconds. All right, hopefully you're done. I walked around. It looked like most people were done. So what did you observe as you looked at your own or looked at your teammates? Anybody have any observations? Xiomara, was your conjecture confirmed by the picture? So you can say that those two lines are parallel. Anyone notice anything else? Anyone notice the title of today's lesson? Anyone know what you just drew? That line that you just drew, line X, segment XY, is a mid-segment. So today's lesson is about a mid-segment, and the idea of a mid-segment and the mid-segment theorem, and you already have drawn one. You didn't even know it. So here's what your picture should have looked like, and again, I walked around, and it looked like everyone had this picture. And so we can clearly see that the mid-segment is parallel to this line. They have the same slope. There's something else that you can see. Watch this. If I take this, put it right there. Anyone have an observation just visually? Anyone have a visual observation? Kamoy? Okay. Very good observation. Anyone have any other observations? Well, we have a picture on a grid. Could we actually do some counting? What is XY and what is CB? Count on your paper. Count them both. Count XY and count CB. They're both perfectly horizontal lines, so you don't need the distance formula. What's XY? This is one of those moments where everybody's hand should frantically be waving because everybody knows the answer. Alexandra? It's 5, you sure? Yeah, it's 5. But what about CB? Caleb? 10. Can anyone put into words the relationship between XY and CB? What's the relationship between the two? John? You said that beautifully. XY is half of CB. I've also given you a cheat sheet as you guys were working for the entire chapter. You will see towards the top some ideas about mid-segments. And you will see that one of the ideas is that they're parallel, and the other idea is that one is half of the other. So we're going to talk much more in depth about these ideas. So does anyone have any questions on today's warm-up or what we just accomplished? Eric?
The picture you mixed up A and C.
Did I?
Yeah.
I apologize for that. I mixed up A and C. I'm sorry about that. Thank you for pointing that out. So this was supposed to be C. This was supposed to be A. Thank you. So this was supposed to be 8. Sorry about that. Hope I didn't confuse you guys too much. Any other comments, questions? Okay, so draw a line across your paper. And today's objectives are to prove and use properties and theorems of triangle midsegments. And so new vocabulary is this big boy word, midsegment. So, a midsegment is a segment that joins the midpoints of two sides of a triangle. Every triangle has 3 midsegments. You can see that in this picture, that these lines inside the triangle are, each one of them is a midsegment. So let me clarify a couple of things about this picture. X is the midpoint of PQ, and we can see that because of the tick marks here and here. That tick mark is indicating that those two are congruent. PX is congruent to QX, which means that's the midpoint. Y is the midpoint of QR. We can see that because of the triple tick mark and the triple tick mark. And that is showing us that that segment is congruent to that one. That means that's the midpoint. When we connect those two dots, those 2 points, X and Y, like this, we form what is called a midsegment. But we can also do the same thing using the other sides of the triangle. So we could come over to point Z. That's the midpoint of PR. And we can see it with the double tick mark. And then if we connect these 2 points, that forms a midsegment as well. We could connect YZ and form a midsegment. And so you see all of the midsegments illustrated in this picture. When you look at the midsegments all together, they form what is called the midsegment triangle. That idea we're not going to explore too much today, but it is something that you should be aware of, that is called the midsegment triangle. Any questions about that? So we've laid the foundation of the idea of midsegment. Now the theorem. The midsegment theorem says what you just proved during the warm-up, that the midsegment will be parallel to the third side. What do I mean by the third side? Well, if I use this point and connect them using to form a midsegment, I've used this side as one of the sides, this side as the other. Now the midsegment is connecting those 2 sides. This is the side that I haven't used yet. And so this indicates that these 2 sides are parallel, and that's what Xiomara had observed right off the bat, just based on the slopes. The triangles will not always be so perfect that you will end up with 2 horizontal lines. In fact, very soon you're going to see one that doesn't. So the midsegment theorem tells us this right here. But it also tells us something else. It tells us that this segment is always going to be half of that. This distance is always going to be half of that. And so we get this aspect of the theorem as well. Here's where it gets a little bit overwhelming visually. If I bring back what I just showed you on the previous page, make sure you're looking up here, because if you're not, you're going to miss it. This is easy to digest right here, because all I have is one midsegment. But when I draw all 3 midsegments, now it gets a bit overwhelming, because this line is parallel to that one. But now we can also say that this line is parallel to this one. because this is a mid-segment, and it's going to be parallel to the third side. Also, we can say that this mid-segment is parallel to this segment. And so we have a lot of relationships, a lot of different ideas, all coming out of one idea. And so you have to be able to keep things straight in your mind. You have to be able to focus on something. You might need to use the whiteout method that I use constantly, using your finger or your hand to block out something. Because it's much easier to see that this line is parallel to this one. If I white out all of this, now it's much easier to see. By the same token, it's easier to see that this is parallel to this. If I white out all of this, it's much easier to see. So using that to help myself, I can hone in on things. I can zero in on ideas or specific things that I'm looking for. Does anyone have any questions or comments about the idea of a mid-segment or the mid-segment theorem? Because we're going to jump right in and start using it. Okay, so example 1. We're going to do kind of an informal proof. We're going to do kind of a visual proof, but we're also going to support it with mathematics. So, the vertices of triangle XYZ are given. M and N are the midpoints of two of those sides. Show that MN, segment MN is parallel to segment XY, and then show that MN is equal to half of XY. Now you see that I already have a grid set up. So we're going to actually do example 1 two ways. We're going to do it visually and mathematically. After that, I'm going to give you a checkpoint. The checkpoint you are going to do purely mathematically. You are not going to draw the picture for the checkpoint. So you have to pay close attention to what happens during this example because you have to get a lot out of it. Anyone have any questions about that? Okay, so let's start by doing the picture. So everyone set up a grid. And look at the coordinates and make sure you set up your grid big enough. Don't go by 2s, go by 1s, so you're going to need to use a chunk of your graphing. So go ahead and we're going to work side by side simultaneously creating this picture. So I'll give you 30 seconds to set up a grid, and then I'm going to start plotting the points. Please try not to go ahead of me because you might end up doing something that's not really appropriate or not valid. And remember, we are not doing guessing. This is not a guessing game. All right, so you should have a grid set up. So let's go ahead and plot the points. X is -1, 8. 1, 2, 3, 4, 5, 6, 7, 8. Y is 9, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. And Z is 3, -4. Let me move this a little bit. 3, -4, right there. I'm going to label my points. This is X, this is Y, and this is Z. And now everyone has a ruler. We're going to connect the points to form a triangle. So if you're sticking with me, then you've got this picture. And now we are told that M and N are the midpoints of xz and yz. So let's start with M being the midpoint of xz. This is not a guessing game. So here is xz. And we are not taking a guess as to where the midpoint is. We might be able to look visually and think we know where it is, but it's not a guessing game. So during the warm-up, you had to calculate midpoint as well. So could someone tell us how we found the midpoint, or how can we find the midpoint of xz? How can we do that? How can we find M? Only one person in my class knows how to find the midpoint? Or we're frantically trying to keep up? I don't think you should be frantically trying to keep up. John? Well, you could do that, I guess, in theory, but then you would have to be able to measure that distance once you cut it in half. You missed a major idea that unfortunately made your life more difficult. Valerie? The midpoint formula, of course, the midpoint formula. M is going to be the average of the x's and the average of the y's of the two endpoints. So, find M. So come on guys, keep up with me, let's go. So we're doing xz. So we have x and z. The x coordinates are -1 and 3. Take the average. Add them together, divide by 2. -1 and 3 is 2, divide by 2 is 1. So the x coordinate is 1. John, you're not frantically writing, let's go. Now the y coordinates. 8 and -4. Add them together, divide by 2. 8 -4 is 4, divided by 2 is 2. So the midpoint of xz, which we're calling M, is at the coordinates 1, 2. So, now we can plot that point. 1, 2. There is the midpoint right there. That is M. Any questions on how we did that? So again, I've said this 100 times this year. This is not a guessing game. We are supporting these ideas with proof. In this case, the proof needs to be mathematical. Any questions on what we've done? John, is it coming back to you now? Good. So now we need N, which is the midpoint of YZ. So we need the midpoint of this line here. Not a guessing game. So we need N. Use the midpoint formula. This is exactly what it's used for. And we are doing YZ, so here's the x coordinate of Y, the x coordinate of Z. Take the average, add them, divide by 2, we get 6. And take the y's, 2 and -4, we get -2 divided by 2, we get -1. So N is going to be at 6, -1. 1, 2, 3, 4, 5, 6, -1. That is N, the midpoint. Any questions on how we did that? There's a lot going on here, ladies and gentlemen. Speak up, speak your mind, ask questions, discuss. Let's get yourself involved. Does anyone have any questions on what we've done so far? To be honest with you, we've basically done nothing so far. We've basically laid out little pieces and that's it. So, we want to do the following. We want to show or prove that segment MN is parallel to XY. Well, we didn't draw MN yet, so let's go ahead and draw that in. And we want to prove that that segment is parallel to XY. So how can we prove it? How do we prove that? How do we prove it? Only one person knows how to prove it. 2 people, 3 people. Sharif?
Calculate their slopes and see if they're the same.
Calculate their slopes and see if they're the same. Beautifully said. So the slope of mn is going to be the slope formula using this. The slope of xy is going to be the slope formula using these. However, look at our picture we have. Excuse me for a moment. So, what could we do to save ourselves time when we have a picture? John, you think you have a way to save time? Don't say it, but you think you have a way to save time? Stephen, you have a way to save time? Because none of your classmates seem to know it. So all your classmates are going to do the slope formula. Anyone who has a quicker way to do it, go ahead and use the quicker way. Okay? I'm going to use the quicker way with a picture. You guys go ahead and use the slope formula. Well, I'm done. I'm not sure about you. Yeah, you have to know everything from this year and last year. So, stop what you're doing. If you're doing the slope formula, yeah, you're going to need to do that in a few minutes. But when we have a picture, there's a much easier way to find the slope. Of course, we do rise over run. Everyone in the room knew that. I'm not sure why we're so quiet. So, rise over run. So we can see the slope of segment MN is going to be negative 3/5. The slope of segment XY is negative 3/5. They have the same slope. So we can now say that segment MN is parallel to segment XY because they have the same slope. Anyone have any questions about that? So now we need to do this second part and prove that MN is equal to half of XY. So this was easy to do when we had this picture here. This was easy to do. Because both lines were horizontal, all we had to do was count the boxes, count the grid lines. So it was easy to find the 5 and the 10. But unfortunately, as I indicated to you earlier, that was not going to be the case. In fact, it usually won't be the case. So we need to now show the distance of MN and the distance of XY and see the relationship between the two. So how do we find the distance of MN? What do we need to do to accomplish that? How do I find MN? Give me a thumbs up if you know how to find MN. Stephanie, how? Yeah, now we need the distance formula. So, MN is going to be the difference of the x's squared plus the differences of the y's squared. So let's look at M. We've got it right there. Difference of the x's. Let's subtract this way. So 6 minus 1 is 5. Then negative 1 minus 2 is negative 3. So MN equals radical what? 25 and 9, radical 34. Well, I'm not sure what we're going to need to do with it, so let's just leave it like that for the moment. But now we need xy, because we don't know if it's a half, so let's find xy and then see what the relationship is. So now we need to do the distance formula for xy. We get the coordinates for xy. Let's see, -1. Difference of the x's squared, differences of the y squared, difference of the x's. Let's see, 9 minus -1 is 10. And differences of the y's, 2 minus 8 is -6. And so we end up with xy being square root of what? Come on, you got it already? What is it? Square root of 136. So we are trying to show this relationship right here. We're trying to show that this segment is half the distance of this one. But right now it's a little bit hard to tell because it's in radical form. It's hard to see if mn is half of xy. In fact, it doesn't look like it, does it? How could we dig a little deeper and see if we could prove it? How could we dig a little deeper and see if we could prove it? I see some people doing something, but you're not saying anything. Sebastian, what is it that you're doing right now?
Finding the radical.
What do you mean finding the radical? We already found the radical. How? Finding decimal. Did you already find them? Okay, so what's mn? Is that exact? Comes out to exactly 5.8? Okay. Okay, so it's approximately 5.8. And what about radical 136? Approximately 11.6. So now can we see it? Now we're looking here and here. Now what do you think? Is mn half of xy? Give me a thumbs up if you think mn is half of xy. Okay, Stephanie, you don't think that it's half. Why not? Did you? Okay, well, I apologize for misinterpreting that. Okay, so they are clearly, one is clearly half of the other. Hard to see when it's in radical form, because remember, this means take the square root, and square roots are very different, okay? So, we did a lot of work here to figure out a couple of things. Yes, come on. So find the midpoint of this, find the distance of that, and compare it with that. That'd be a cool approach. You're the first one to bring it up. I bet you that would work very well. So when you do the next one, I want you to try that approach. Okay? All right, so we did a lot. First, we had to find m and n. Then we connected them. That became a mid-segment. Then we proved that they are parallel by showing that the slopes were the same. Then we were asked to show the relationship between the distances, which we did using the distance formula. A lot of work involved here. Anyone have any questions? Okay, checkpoint number 1. you're going to work as a team, so I'm calling this a team checkpoint, but you are not allowed to draw the picture. Now you must do everything without the picture, but you already know what to do. So we'll put 5 minutes on the clock, work with your team, figure things out, compare results, come to some conclusions. We're trying to informally show that Mn is parallel to Rs and that Mn is half of Rs. If you have any comments or questions, just raise your hand and I will come to you. looks like we're still working. Give me a thumbs up if you were able to demonstrate both ideas. Okay, a couple of people. Okay, got another minute on the clock. Finish what you can. All right. So we already know what the end result is. We already know that they're parallel, and we already know that that Mn is half of Rs. So how were you supposed to demonstrate it? Well, let's start with M and N. The coordinates, those coordinates were critical. You needed to use the midpoint formula to find M and the midpoint formula to find N. From there, proving the two lines parallel, you needed to find the slopes. The slopes of segment MN and RS were both what? What were the slopes? Stephen, what'd you get? They were both 3/2. And so that proved that segment MN was parallel to segment RS. Now demonstrating the distances. Using the distance formula, you get Mn is radical 13, or if you use a calculator, it's approximately 3.6. Rs, if you simplify using the techniques you learned last year, you get 2 radical 13. But if you use a calculator, you get approximately 7.2, and either way you can see that Mn is half of Rs. Either way you can see it. So, any comments, questions on any of the work we've done here? A lot of work involved. Any comments, questions on anything? Okay, so now let's take the idea of mid-segment and use it to solve some problems, now that we've gotten very comfortable with it. I'm going to say for these examples, you do not need to copy the picture because they're a little bit complex, and this is actually going to go pretty quickly. So write down example 2 and write down what we're looking for, but you just have to trust that you will understand just from the experience. So now, using the idea of mid-segment, using the mid-segment theorem, find the different measures. Part A, find BD. So we would like to find the distance from here to here. What can we do? Okay, give me a thumbs up if you already know the distance of BD. Got 1, 2, 3, 4. Only 4 people know the distance? Okay, you got 1 minute team talk to figure out how to find the distance of BD. 1 minute team talk, go.
words actually uttered?
Why is it there? It's 6.2. Take away the 6.2.
Oh, because,
You all agreed on that? Oh, okay. Well, there was a lull in the conversation, so I'm guessing that 1 minute was too much time. So now give me a thumbs up if you have an idea of how to get BD. Oh, okay, so now we got some more confidence. Dainara, how can we do it? Why? And how do you know? Yeah, that's an E, by the way. Sorry about that. That's an E. So how do you know that it's half? Very good. The mid-segment theorem says that this mid-segment, and we know it's a mid-segment because of these markings here, that's telling us it's a mid-segment. That's going to be half of this distance. So all we need to do is 17 divided by 2. And so, Kayla, you got 8.5. We don't know the units of measurement, so you could say 8.5. You could say 8.5 units. Doesn't really matter. Any questions about that? Okay, no comments or questions? All right, let's go to part B, finding the measure of CBD. So I would like to know the measurement of this right there, that angle. Give me a thumbs up if you think you know what the measurement's going to be. Okay, Matthew, what's the measurement going to be? 26 degrees. Why? Oh, wow. That was pretty good. So, first of all, it was a little bit of a giveaway because there's only one angle measurement in the entire picture. So you knew that it was either going to be 26 degrees or some relationship between 26 degrees. And he's right, it is 26 degrees. But now let's talk about alternate interior angles. He says that it's alternate interior angles, but how? How is that true? So I'm going to give you 1 minute. I'll say this, he's right. But here's the part that was a little bit strange for me personally. So which two parallel lines do you use? Which two parallel lines do you use? So you got 1 minute as a team, figure out which two lines are the parallel lines we're going to use. Okay, once again, there's a lull, so I'm guessing that we don't need a full minute. So I'll cut the time. Give me a thumbs up if you think you and your teammates know which two lines are the parallel lines we need to prove this. Okay, some teams think they do something, some teams do not think they do. Kalasia, which two lines did your team think were the parallel lines? AC and FD. Okay? Stephanie, your team also thought that you had it. Which lines did you agree on? So you agree with this team. So let me add in lines so we can see it. So you think that it's this line, and I'm going to extend it a little bit just for the heck of it, and this line here. And yeah, that is absolutely correct. How do you know that those two lines are parallel? How do you know that they're parallel? Kamoy? The mid-segment theorem tells us that they're parallel. Okay? What I got stuck on personally was I got stuck on these two lines. I kept looking at this line and this line, trying to figure out how to make it work, and I was having trouble. It wasn't until my brain kind of turned the picture a little bit for me that I saw that this and this were alternate interior because of these two parallel lines. So you really got to get your brain to work with you and focus on the right spot, okay? So hopefully you guys were able to do that. Any comments or questions on the angle relationships? Okay, so let's go one step further to part C. I would like the distance of AC, and let me get rid of my parallel lines that I drew. We would like the distance of AC. Give me a thumbs up if you think you know how to find it. You don't need the answer, I just want to know if you know how to find it. Some people think they've got it. Okay, Alexandra, what do you think we're going to do?
Add symbol. I don't know how to say it. Multiply 6.2
Why?
because it's half of 6.
Very good. So this distance right here is going to be half of this distance because of the mid-segment theorem. We're given this distance, so if we multiply it by 2, we will get AC. So you said, I don't know how to say it, but you said it perfectly.
Add 6.2 twice, or I don't know.
Well, either way, it works. 6.2 times 2, so what is AC? What does it come out to, John? Comes out to 12 point. Very good. Anyone have any comments, questions on how we accomplish that? Good, we're doing well with the mid-segment theorem. Let's see how you do on your own. You do not need to copy the picture, but you need to find each measurement. You got 3 measurements to find. I'm going to give you 2 minutes. 2 minutes. Of course, if you have any comments or questions, you can ask a teammate or you can ask me. Remember, the equity bars are in full effect, so be prepared to explain. All right. Equity bars in full effect. Be ready to give answer and explain. Part A, I need the distance of JL. I got students 3, 13, and 2. Student number 3, what'd you get?
8.5.
Student number 13, what'd you get?
72.
Okay, student number 2, what did you get?
72.
So, the distance of JL is 72. 72. What about the distance PM? What is the distance PM? I've got student 5, 16, and 7. Student number 5, what'd you get? Student number 16, what'd you get?
$48.5.
So you agree. And student number 7, what did you get?
48.5.
So you all agree that it is 48.5. Now the tough one. What's the measure of angle MLK? I got student 19, 1, and 15. Student number 19, what'd you get? 102 degrees. Student number 1, what'd you get?
102 degrees.
Student number 15, what'd you get? You all agree that it's 102 degrees, and it is, but who's going to be the brave one to explain why? What is the reason? Eric?
Same side equals.
You got the right idea, but that's not the right theorem. There's a different idea. Stephen?
Corresponding.
Yeah, they're corresponding angles. This corresponds to this because this is parallel to this, and that is the transversal. Same side is this one in here. That's same side interior, okay? So just be careful of that. So, very good. Anyone have any comments, questions on any of these? Kayla, did you find your mistake on part A? You just misread it, but you got the other one? You got the other two? Very good. Any comments or questions? So let's finish off by throwing in a little algebra. Find the value of n. Find the value of n, you've got 2 minutes. If there is still time on the clock when you're done, you are welcome to team talk to see if you got the same value. Of course, if you have any problems or questions, just let me know and I will come help you.
Like if you look at it, I think it's the mid segment and I feel like it's the mid segment. Twice.
What I figured I did.
Yeah, 2 times.
All right, equity bars in effect. Let's see how we did. What is the value of n? I got student number 21, 4, 6, and 16. Student number 21, what'd you get? Student number 4, what'd you get? So I got 2 people who agree on an answer. Student number 6, what'd you get? And student number 16, what'd you get? Okay, so we have a slight disagreement. 16 is the value of n. And there were 2 different ways to approach it. Could someone tell us what you did? Kamoy, what did you set up? Like that? Or just flipped around? Anyone do it differently? Well, there is another way to do it. You could have cut the other segment in half. Either way, you get the same results. Stephanie, you had said you had gotten a value of 1. Do you know where you went wrong?
Yeah.
Okay. Was it because you set them equal to each other?
No, I divided them.
Okay. Does this make sense to you now?
Yeah.
Okay. So this is based on the mid-segment theorem that allows us to say that this segment is half of that one. Any comments or questions? Okay, we did very well with the concept today. Draw a line across your paper. Your homework is on page 300. You are doing numbers 3 through 11, 24 to 26. And then you see these 4 questions in bold. That's where the bulk of your time will be spent. They are not proofs, but they are more complex questions. 28, 38, 39, and 40. It works out to a total of 16 questions or 16 points. Please read the next section or do the at-home tutor online. You have your Chapter 4 test on Friday. And you also have a semester exam. Next. All semester exams are going to be during our long block, which is third block.